method and paper airplanes. So today we get down to the experiment. We started with the question, what happens when I change the wing size? Will the plane fly farther or not? We did our research on paper airplanes, what makes paper airplanes go far. We made a hypothesis. I think that if the wings are fatter, it will go farther. If the wings are fatter, then it will go farther. Well, now we are going to work on the experiment. Okay, so in the experiment, we have different variables. You can see we have an independent variable. What causes the change? So this is where we change wing size. Okay, that's the independent variable. The dependent variable, changes in the independent variable, causes changes in the dependent. So the dependent variable, you can manipulate the plane, okay? You can add paper clips, so you can add weight. You can change the paper. You can construct planes from different types of paper. Newspaper, magazines, copy paper, cardstock, construction paper, etc. The location. Are you inside your house? Are you outside where it's windy? Things like that. And then you can change the size of the paper airplane, or you can attach something for drag. So you can change that. Those variables would end up in the independent variable. Then this is the changes in the independent variable that causes changes in the dependent variable. Okay, what's constant? What always remains the same on your paper airplanes? Are you always using the same paper? Are you always adding a paper clip? What do you use that remains the same? And then we get into the materials that you need. So you're going to conduct your experiment. You need certain materials. You need what kind of paper you used. You need, if you used a paper clip, you need to write down anything that you used. Did you use a fan? Anything that you used that you would need to conduct your experiment. The scientific method and the paper airplanes, this is your data collection table. So trial 1, what wing style did you use? Okay, and trial 1, you have 3 different wing styles. So you can pick skinny, fat, bumpy, whatever wing style you used, okay? And you're doing 3 different tries. So the first paper, you have 3 different wing styles. The second one, you have 3 different wing styles. The third one, you have 3 different wing styles. On average, these wing styles all have to be the same in each trial. So if you used really tight, skinny wings in trial 1, trial 2, you'd have to do the same thing. Trial 3, you'd have to do the same thing. And on average, how far did it go? Wing style 2, trial 1, your wings are bigger. They're longer, they're fatter. You would use the same wings here that you do in trial 2 that you do in trial 3. So you would make the same paper airplane here. And on average, what happened? And then wing style 3, what happened? Okay, sketch your plane for each trial that you use. So plane 1 looks like this with the skinny wings, plane 2 is the fat wings, and plane 3 is the bumpy wings. Once you get that, you add your data to the graph. Okay, so you have going trial 1, trial 2, trial 3. And if you go back, you have wing style 1, 2, and 3, but you have the distance that it went, okay? The distance that it went, the style of wings. And on average, you're going to put your data points, your bars, okay? So you need to make sure that you are collecting your data on your experiment, okay?